Good morning, everyone. In this particular video lecture, we will start Unit 2 of the subject named Electrical Circuit. And basically, the Unit 2 is regarding the single phase AC parallel circuit. Now, my dear friends, the first topic we will discuss in this chapter will be parallel RL circuit. As you can see here in the given diagram, that there are basically two elements. The first one is resistor here, and the second one is basically inductor here. Both these two elements are connected in parallel with each other. Now, my dear friends, as you can see here the voltage source is basically denoted by V, and the current flowing current overall current of the circuit is denoted by I here. And this is basically, we can say, node A, and the current flowing through the resistor is denoted by IR, and the current flowing through the inductor is denoted by IL. Now, my dear friends, first of all, we will, as you can see here, if we apply KCL at at node A, then basically I will be basically according to the KCL, I will be basically IR plus IL. So my dear friends, we also know that the current across resistor, if you want to calculate, then its formula will be basically B by R. And if you want to calculate the value of we can say current across the inductor, then that will basically V by JXL. So my dear friends, as we proceed further, then as you can see here, basically we have taken V as a common, and then basically I by R plus I by JXL will be remaining. And then my dear friends, as we move further and send my dear friends V to the left hand side, then this will basically becomes I by V is equal to 1 by R plus 1 by JXL. And now my dear friends, as we know that V by I is equal to R, V by I is equal to R. So my dear friends, I by V is equal to, we can say, 1 by R, means reverse of reciprocal of my dear friends resistance. So my dear friends, as you can see here, basically I by V is equal to 1 by R plus 1 by JXL. And now my dear friends, basically because this is the reciprocal of resistance, so here its unit will be the reciprocal of resistance. We can say it as Ohm or Simon or Ohm inverse, my dear friends. So the whole equation, that is 1 by R plus 1 by JXL, is basically denoted by Y here, and that is known as admittance. So my dear friends, if you want to calculate, then I by V is equal to Y, and here basically Y is equal to 1 by R plus 1 by JXL. And my dear friends, Y is known as the admittance of the circuit. And here, as you can see here, I is equal to V into admittance. And admittance is basically, my dear friends, we can say admittance is basically, as we know, Z, that is impedance, is, my dear friends, I by V, we can say. My dear friends, as we know, the resistance is basically V by I. So my dear friends, we also know that in case of series circuit, this is basically denoted by Z, that is impedance. And now my dear friends, here admittance is basically equal to I by V. So we can also say that Z is equal to 1 by Y, or we can say that Y will be equal to 1 by Z. Y will be equal to 1 by Z. Now my dear friends, as you can see here, there is a relationship between the admittance Y and we can say the impedance Z, that Y is equal to 1 by Z here, as you can see. Now my dear friends, if we talk regarding the we can say the unit of admittance, then that will basically the reciprocal of resistance, and reciprocal of resistance or impedance is known as basically Simon, Mho, or we can say, my dear friends, Ohm inverse. Now my dear friends, as we know, admittance Y is equal to 1 by R plus 1 by JXL. And in case of, my dear friends, if we send this positive J above, then it will basically becomes negative, and the whole equation becomes 1 by R minus J by XL. Now my dear friends, 1 by R is basically, as you can see here, 1 by R is basically denoted by G here, and this is basically known as conductance. And basically here 1 by XL is denoted by BL here. And now my dear friends, if we talk regarding the abbreviation, then as you can see here, basically the Y is known as admittance, and G is basically known as conductance, and BL is basically known as inductive susceptance. Now my dear friends, as you can see here, the unit of admittance, conductance and susceptance is basically same, that is mho or ohm inverse, or we can say Simon. And here Z, that is conductance, is equal to 1 by R, and my dear friends, BL, that is inductive susceptance, is equal to 1 by XL, my dear friends. So this is basically the derivation regarding the admittance. And now my dear friends, first of all we will draw the admittance triangle. Now my dear friends, basically the circuit is parallel RL circuit, and we also know that in parallel, basically the value of voltage is same across all the resistor, or we can say all the conducting elements. So here we will take voltage as a reference. And now my dear friends, if we want to draw the we can say the phasor diagram, then this is basically the voltage, and the current through the resistor will be in the same phase. And my dear friends, as we know, the current in inductor basically leads the voltage by 90 degree. So my dear friends, this will be basically the current across inductor. And now my dear friends, if we want to multiply uh, my dear friends, if you want to basically find out the admittance, then obviously this will be basically my, as you can see here, this is basically the inductive susceptance. So this will basically denoted by BL, we can say, and this is basically denoted by G, and G is equal to, my dear friends, as we know, 1 by R, means reciprocal of resistance, is known as conductance, and this is basically, my dear friends, admittance. So my dear friends, from here we can say that Y is equal to G minus JBL, and if you want to calculate the value of we can say, my dear friends, magnitude of Y, then that will basically comes out to be G square plus BLK square. And from this triangle, my dear friends, if you want to calculate the value of tan phi, then that will basically comes out to be VL by G. And from here, if you want to calculate the value of phi, then it will basically comes out to be phi is equal to 10 inverse VL by G. And if you want to calculate the value of power factor, that is cos phi, then that will basically G by Y, my dear friends. And from here we can calculate all these parameters. So my dear friends, the main focus is to basically draw the admittance triangle. First of all, we will draw the admittance triangle. Now my dear friends, this will be basically the voltage as a reference, and this will basically the current across inductor, IR, we can say, my dear friends, and this will be basically IL, we can say. Now my dear friends, IR means we can say, my dear friends, IR. In IR we can say there is basically a resistor. This is basically the current across the resistor. And my dear friends, we also know that G is equal to IR. So this will be basically denoted by G. And my dear friends, this is basically the current across inductor. And in this equation, my dear friends, in this equation, if we talk, then basically BL is the inductive susceptance. And my dear friends, this is basically the current across inductor, and this is basically the we can say inductive susceptance. So here we will take BL, basically we can say. So this is basically the admittance triangle. And now we will basically calculate, we'll draw basically the power triangle. So my dear friends, we know that basically I is equal to IR minus JIL. If we replace basically in this equation, if we talk, my dear friends, if in this equation if we talk, then as you can see here, in this equation, if we basically replace this by I, and this is basically G, means inductance, that is 1 by R, then this will basically becomes the current across resistor, and this is basically BL, means inductive susceptance. So this will basically becomes current across inductor. So if we replace all these things, then our equation will be comes out to be, as you can see here, I is equal to IR minus JIL. Now my dear friends, as we know, power is equal to V into I, means voltage into current. So if we multiply this I by V, then then our equation will basically comes out to be something like this. As you can see here, V into I is equal to V into IR minus JV into IL. Now my dear friends, V into I is basically equal to S, as you can see here, and V into IR is basically equals to P. And my dear friends, V into IL is basically equal to QL here. Now if you want to calculate the value of magnitude of S, then that will basically root under P square plus QL square. And in the same way, my dear friends, from this triangle, in the admittance triangle, you have already seen that this was basically the resistive component, this was basically the inductive component, and this was basically the net or we can say resultant. So my dear friends, in the same case, this will be basically the resultant, and this will be basically P, that is the, we can say, the powered across resistor, and this will basically QL, that is we can say the powered across or we can say the drop across inductor, my dear friends. So now we will basically discuss the next topic, that is RC parallel circuit. Now my dear friends, as you can see here, this is basically the circuit diagram of RC parallel circuit, and as you can see here, basically there are two components. The first one is resistor and the second one is capacitor, and both these two components are connected in parallel. Now my dear friends, if we apply basically we can say KCL at node 1, then basically our equation will be comes out to be I is equal to IR plus IC, my dear friends, as you can see here. Now if we put all these value, that is IR is equal to, as we know, IR is equal to V by R, and as you also know that the current across capacitor is V by minus JXC. Basically minus sign indicate that basically minus sign indicates that the voltage basically lags in case of capacitor. Now here from here, if we take V as common, then the equation then our equation only comes out to be something like this. And my dear friends, if we basically send these the value of voltage to the left hand side, then our equation becomes something like this. And here the same case, that is admittance is equal to 1 by R plus J by XC, my dear friends. Now the whole equation is denoted by admittance Y, so we can calculate the value of current from here, that is I will be equal to V into Y, that is voltage into admittance. Now my dear friends, as we move further, then the admittance will be 1 by R plus J by XC. Now as you can see here, 1 by R is denoted by G and 1 by XC is denoted by BC, that is capacitive susceptance. Now my dear friends, this will be admittance and its unit will be ohm inverse, or we can say mho. This is basically conductance. It is equal to 1 by R, means reciprocal of resistance, and its unit is basically mho, or we can say ohm inverse. And this is basically capacitive susceptance, and its unit will be basically, we can say, the mho or ohm inverse. Now my dear friends, next we will draw the phasor diagram. For drawing phasor diagram, my dear friends, this is basically the parallel circuit, so we take voltage as a reference, and we know that the current across basically resistor is in phase with voltage, so here we have denoted IR, and we also know that the current across capacitor basically leads the voltage by 90 degrees, so we have denoted this by IC, and this will basically the equivalent, we can say, current. Now my dear friends, from as you also know that I is equal to IR plus JIC. Now from here we can calculate the magnitude of I, and from this triangle, from this phasor diagram, we can basically calculate the value of tan phi power factor, etc. And basically my dear friends, basically this is as we know that the circuit containing resistor and capacitor is leading in nature due to the capacity due to the presence of capacitor. And my dear friends, we also know that the circuit containing resistor and inductor will be lagging in nature due to the presence of inductor in the circuit. Now my dear friends, next we will draw the admittance triangle. As you can see here, my dear friends, as you can see here, basically this is the resistive component, and the resistive component is Z is equal to 1 by R. So here we have denoted it by G, and this is basically the capacitive component, so we have denoted it by we can say BC, that is capacitive susceptance, my dear friends. Now as you can see here, as we already know that the Y is equal to as you also know that Y is equal to basically G plus JBC, my dear friends. If you want to calculate its magnitude, then basically the formula will be magnitude of Y is equal to root under G square plus BCK square. And from the triangle, my dear friends, we can easily calculate the value of tan phi and power factor, my dear friends. Now we will move to the next topic, that is power triangle. Now my dear friends, as you know that basically this is the resistive part, and as we know that the power across resistor is equal to P is equal to V into I V into IR, my dear friends. So this is basically the power across resistor, and this is basically the power across, we can say, capacitor, and this is basically the equivalent power. Now as you can see here, as we know that I is equal to IR plus GIC. Now my dear friends, if we want to find the value of power, then as we know that the value of power is equal to V into I. So here we have multiplied both the equation by V, and our equation basically comes out to be S is equal to P plus JQC. If you want to calculate the magnitude of S, then that will basically comes out to be root under P square plus QC square. And in the same way, my dear friends, we can easily calculate the value of phi, tan phi, and power factor, and this will basically leading in nature. Now my dear friends, this was all about the series, we can say, parallel RL circuit and parallel RC circuit. Now my dear friends, I hope you have enjoyed this video. That's all. Thank you.